All right, so in this video, we're going to prove that this identity is true. And so to do that, we're going to start out by rewriting the right side of the equation right here. And so using this, our goal is to deduce the left side of the equation. Now, the first thing that we're going to do is we're going to multiply both the numerator and denominator by 1 plus the sine of x. So when we multiply these two fractions, we're overall going to get a single fraction. So then what are we going to get in the numerator? Well, essentially, we're going to be doing 1 plus sine x times 1 plus sine x. If you do that, you're going to get this. And as for the denominator, if you do 1 minus sine x times 1 plus sine x, that will leave you with 1 minus sine squared x. But we know that 1 minus sine squared of x is the cosine squared of x. So this is what we would get. And now what we can do is we could split up this fraction into a sum of 3 fractions. Just like this. And so now that we have this, all we got to do is rewrite these in a different way. Now we know that 1 over cosine squared is secant squared. Okay, so then what about this middle term? Well, what we're going to do is we're going to break this up into a few pieces. We can all agree that this is equal to this, but we know that sine x over cosine x is tangent x, and 1 over cosine is just secant x. And I don't know about you, but I like when secant comes before tangent. That's just me, right? Like, that was good. So I like seeing it like this rather than like this, right? That was good. So we know that this middle term is just 2 secant x tangent x. And for our last term, we know that sine squared over cosine squared is just tangent squared. And so really, this is what we have now. But notice that what we have here is in the form of a squared plus 2ab plus b squared. And if you recall, anything in this form is the same thing as a plus b squared. We can let a be secant of x and let b be tangent of x. So overall, this is secant x plus tangent x squared. Now, it turns out that we're allowed to move the exponent of 2 to the outside of the absolute value. Like this. And the reason why we're allowed to do that is essentially because this is true. And the reason why this is true is because if I have something like absolute value of a squared, well, this is the same thing as the absolute value of a times a. But if you recall, there's this property of absolute values that says that we're allowed to split this up into a product of 2 absolute values. Like that. And this is just absolute value of a squared. And so that is the reason why this is true, which is why we're allowed to move the exponent of 2 to the outside of the absolute value. And so the next thing that we're going to do is we're going to move the exponent of 2 to the outside of the natural logarithm. If you recall, that's just the logarithm power rule. As you can see, the 1/2 and the 2 cancel out, so you're left with this. And so as you can see, this proves that they're identical to each other. And so yeah, that's pretty much the way it works.